Let's talk all about AI in business. It's hosted by Brent Mueller. Welcome to the Future Proof Podcast.
Hi, and welcome to the latest episode of the Future Proof Podcast. I'm your host, Brent Mueller. I'm joined today by Matt Kolmes from Supreme Corporation. Matt, glad to have you. Welcome.
Yeah, thanks. Thank you for letting me be on the show.
This can be a fun one. So, Matt, first, we always start with, the founder's journey. So talk to us about your background and leading up to becoming the leader there at Supreme.
Yeah, well, for me, my career has been a whole series of left turns where I've made 7, 8, 9 left turns, and I've ended up kind of where I never thought I would be. But my father, who passed away in 23, he was the owner of Supreme Corporation. And I worked here when I was in high school. I worked here during the summers in shipping and receiving. I worked in maintenance. I was a helper on the truck. I eventually made yarn deliveries. I was a yarn salesman in college, but I wanted nothing to do with textiles. And so when I graduated from college, my dad asked me if I wanted a job. And I said, I'd rather you hit me in the forehead with a hammer than do anything with yarn or textiles. And he said, okay. And I went to grad school and I became a litigation attorney, and I burned out. After about 5 years of litigation, I was a New York State court litigator. And after about 5 years of doing that every day, I didn't want to do it anymore. And I came to the conclusion that everybody was miserable, including me. My clients were miserable, judges were miserable, court officers were miserable, my clients were miserable, my law partners were miserable, and I just wanted to do something where I could be happy. And I decided to go back to grad school. And I remember I was talking to my father, and he was launching a clothing brand of cut-resistant safety clothing called Tough and Light. And he said, well, you're a hard worker and you obviously don't need anybody to push you every day to work hard. And I really need help to launch my brand. He said, I'll make you a deal. You come to work with me and help me launch my brand, and I'll pay for the MBA because I wanted to go back to school. I was interested in finance. I was also interested in marketing. I was interested in business. And, I still don't know what I want to be when I grow up, but I figured I better, get a degree.
All of us, right, that are entrepreneurs, 100%. I love that you said that.
Yeah, I was like, I still don't know, but I knew I wanted to do something involved with business, and I figured grad school would help me, focus in on that and get an MBA in business and try to find another career path. And something interesting happened. I came to work here in September of 2007. I immediately started with a team of other people, started traveling all over North America, selling safety jackets. And then we had a customer in South America, and I went there. And then I ended up going to Japan, and I loved it. I loved what I was doing. And so in December of 2007,
what a cool change, by the way.
Yeah. My father asked me, have you applied to any MBA programs? And I said, no. And he said, what do you mean, no? What are you going to do? And I said, I love what I'm doing. I'm going to stay here. And he just smiled and he said, okay. That was fine with him. And, he always needed more help, and there's always work to do here. And so I became a sales guy for the company full time. And that's really all I did. I had no decision-making power. And even though I was the SOB, or the son of the boss, I really didn't tell people what to do or, get involved in decision making. And after about 3 or 4 years of that, I started to get very opinionated because I felt like things weren't being done in an efficient way. And I felt like bad decision making or cloudy decision making was happening. And I kept saying, if you'll just give me the ability to make some decisions, I think I can guide us on a really good path. And what I was hearing from my father was like, you're an attorney. What do you know? You don't know anything about manufacturing. You don't know anything about running a company. You don't know anything about yarn or textiles. What happened was I started getting more involved in operations, but there was a man who challenged me, and he was a vendor of ours, and he came in, and he was an extremely wealthy guy. His company was making then $350 million a year. In my eyes, he was a huge success. His name was Mo Kassam. And his company is Midas Safety. Now, he's since sold that company and moved on. But Mo came in and he asked me some questions, and he squinted at me and he said, you're just like my son. And I said, what do you mean by that? And he said, well, if you owned a car company that manufactured automobiles, you would know everything about cars. You would know about the wiring harnesses and the batteries and the fuel injection and the mufflers and, the tires and the wheels and the bearings and the lights. And he said, you are essentially an owner of a textile company and you don't know anything about textiles. And he said, that's a shame. And I don't think he realized how seriously I took that, but that really bothered me. And I think I processed things slowly and it built up over time, over like the next 2 weeks. That was around 2011. I realized that I needed to learn everything I could about textiles, every yarn, every fiber, every machine. And I just started embedding myself with the yarn engineers, the plant manager, operations people, and I started trying to absorb everything I could about textiles. And my wife had said to me at the time, my father was a yarn engineer, not by education, but by doing it every day.
By doing, right? Yeah.
Yep. And he had 2 or 3 other people that would do it. And we had a scientist who was a physicist and a chemist on staff. And my wife used to ask me, well, your dad can't work forever. Eventually he's going to retire. Who's going to design the yarn? And I told her, I don't know. I'll find somebody. I'll hire somebody. But I struggled with that. My wife is she gets to the point very quickly. She was like, new talent is needed because old talent may be leaving. And she was absolutely right. And so, Mo had challenged me. He said, you don't know anything about yarn. And that bothered me. And about 2 years later, I said to my wife, we don't need to hire a yarn engineer because I've got it. She said, are you sure? And I said, yeah, I'm sure I've got it. By that jab or that insult, he inspired me to grow and push myself to learn more and to improve. And I really thank him for that, because until I looked in the mirror and he said, you're like my son, you're like a selfish, spoiled kid, and you got this great thing handed to you and you don't know anything about it. You're not engaged in trying to like grow it. So, he challenged me, and that's how we learn and that's how we grow, is by looking in the mirror. And you always got to ask yourself, like, all right, I know what I do really well, but what am I average at? And what am I, below average at? And like my kids, I try to teach them the things that they're not doing well, how to get average at those, and become
level up. Yeah.
So that's kind of how I got here. But I was very lucky, because we had a physicist chemist. His name is Jim Threlkeld. And Jim came to me around the time that I was starting to get interested in yarn and composite yarn. And he said, I don't really feel like anybody in this company has a real scientific knowledge of technology. And I said, I think that's accurate. And Jim was paid to develop technology for us. And he was a brilliant guy with 200 patents, and he'd worked for Chemstrand, which was a company in Charlotte that eventually went bankrupt. Chemstrand had PhD scientists that were hired by Monsanto to develop AstroTurf. So Jim was on the team of scientists that developed AstroTurf, and he was a brilliant guy. He was also a very short-tempered guy, and he was like most geniuses. He was hard to be around. He would get mad, throw his notebook across the room, and he had all kinds of antics. People would tell me that I was the only one that could really put up with Jim, but I wanted to learn from Jim. And Jim said to me, if you want to learn textiles and you want to learn technology and scientific method and how to run an experiment, build me a lab at Supreme and I'll come every day and I'll teach you. And I did. I built that lab. It didn't cost us much money. And I embedded myself with Jim, and I worked with Jim every day from 2011 to 2019 when he retired. So I'm really a student of Jim Threlkeld, and we ran back then a lot of scientific experiments. We did ballistic briefs for the military to catch IED frag, where we hand-loaded shotgun shells and we fired into fabric to show that we could catch fragmentation at 600 feet per second with a fabric made out of para-aramid. And we applied for a patent, and we got a patent on that knitted structure. And it worked the way Jim described it, that it's the way a professional baseball player catches a baseball. He said, when you have a ballistic vest, you've got many layers of tightly woven Kevlar, and you slow the projectile down by turning the projectile's energy into heat, and it dissipates on the fabric. And he said, I'm going to do it a completely different way. Look at a baseball catcher. Baseball catcher holds their hand out, and when the pitch comes, the glove absorbs the energy, kind of like a pillow. And he said, that's how we're going to slow that frag down and catch it and not let it penetrate. And so we built this handmade device based on a book that was written in the 1770s by a guy named P.O. Oakley. And there was something, and it's up on the wall in my lab. It's called the Oakley equation. And Jim was a firm believer in fundamentals. And Jim used to say to me all the time, how can you do complicated things if you don't have strong fundamentals? We need to learn to do simple
I totally
things.
agree with that statement. Yes.
Yeah. Well, he did. He said, we've got to do simple things really well before we do medium and advanced things. And then he was a firm believer in that. He had a lot of beautiful like hypotheses about how things work, right? Like in business, Jim said to me, America's unique because you've got all these really big companies, but they're, a big company is like a huge elephant. It needs to constantly eat. It needs revenue. It needs profit. It needs cash. It needs all these things all the time in order to survive. And if any of those things are missing, it withers and dies. And he said that doesn't lend itself to invention. And he said innovation is done by small or mid-sized companies or people working out of their garage or their basement. And then he said, the beautiful thing about America is I think we do it here possibly better than it's done anywhere else, is that we have small and mid-sized companies inventing technology. And then we have mid and large-sized companies acquiring them and taking them to the next level. So Jim believed in this sort of conveyor belt of invention leads to capital, leads to growth. And so I believe in that too, which is why I have 2 startups now. But we were working with Jim and we built this basically barrel hanging from the ceiling. And then Jim knew the mass of the barrel. And then he put a device behind the barrel to measure the movement of the barrel when we shot a shotgun into it. And with that and the Oakley equation, he could determine the speed of the projectile. So we did all this textile testing, and we eventually came up with this fabric that we knew was going to pass the test. And then it came time to spend the real money. We went to Chesapeake Lab, and we did ballistic testing on our blast brief, our underwear for servicemen and women that were getting hit by IEDs in Afghanistan. And they were surviving the blast, but they were dying from secondary infection from grains of sand would then get embedded in their groin area. And the sand couldn't be removed because it was too small. And it was dirty and it would cause infections, and the infections were leading to deaths. We went up to Chesapeake Lab. Jim didn't go. Jim was quite a bit old. In 2019, I think he was in 81 or 82. So I went up to Chesapeake with the fabric. It was laid up in chute packs, and we shot the chute packs. And the testing that we did at Chesapeake was within 0.1 of the testing we did on our own equipment. And I remember that the lab manager came down, and like any lab manager, he was doing PR and marketing to try to, grow his business. And he said, hey, thanks for coming in. Thanks for doing the testing. By the way, what equipment do you have at Supreme? And I was embarrassed. And I said, well, we have, some homemade equipment. And he said, what is it? He's like, you got a laser gate? And I was thinking, laser gate? No, we got a 55-gallon garbage can hanging from some 2x4s with some wire. And when I told him, he said, well, that's phenomenal. He said, you were able to build a device and use math like a calculator with the Oakley equation to measure the speed of the projectile. And I said, yeah. And then he showed me their software. And there they had laser gates for the projectile, and everything was computed by the software to determine the velocity of the projectile. And so I remember I was excited, and I left and I called Jim just to say, hey, not only did we pass the test, but the device that we built was accurate to 0.1 of the results we got at Chesapeake. And Jim had no emotion, pure scientist. He goes, oh, that's great. And I said, well, wait, what do you mean that's great? Don't you feel like that's a big accomplishment? And he said, Matt, it doesn't matter if it's a laser gate or a 2x4 with a barrel hanging from it. He said, physics is physics. And so he said, no, I'm not surprised. We built it correctly according to Oakley's diagram, and we used the Oakley equation, and no, it's exactly what it should be. And he said, no, I'm not surprised. That's the result that I expected. So I was blown away. And, with Jim, we did so many projects for other companies because we had the capability to do it. I remember we were out at Oakley. This was back before Oakley got acquired. And they had brought us in for a completely different reason. They brought us in to do abrasion-resistant twill because people were taking a knee in operations or getting scraped on rocks, and they were destroying their pants. And we make very high-strength yarn, and Oakley had wanted us to come and engineer this cut-resistant, abrasion-resistant fabric. And when we were out there, one of the product designers said to me, you guys know anything about finish, like textile finish? And Jim, having come from ChemStrand, was an expert at textile finish. And I said, yeah, sure. We know a little bit about textile finish. And he said, let me ask your help to solve a problem that we've been working on for 2 years. And I said, okay. And this guy, his name was Jeff Sumokal. He was in footwear, but he was
Things,
kind
right?
of pollinated with the other people at Oakley, which is a very, compared to us, extremely large company. And
Right.
he said, we have board shorts for surfing and we test them in Catalina seawater. And I said, why Catalina
Yeah,
seawater?
why?
And he said, because there's more heavy metal in Catalina seawater than anywhere else, and it stops the fabric from drying out. And so he said, could you treat our board shorts and get them to dry in less than 5 minutes? I think at that point, Oakley was getting them dry in 18, 19, or 20 minutes, and they wanted the board shorts to dry in 5 minutes or less. And so I took that problem to Jim, and Jim, he said, well, we have to do research. He said, most problems that you solve have been solved before. You've got to look it up, see what other people have done. So he did some research and he came back and he said, C8 chemistry is going to be outlawed in California soon. So we can't use C8, but 6 is good. So we're going to use 6 chemistry. And then we've got a proprietary way to apply it to the fabric. And I said, what's that proprietary way? And he said, I'm going to build you a machine that will put more of that chemical on the fabric than other people can get on there. And I said, how are you going to do that? And he said, you'll see. He said, I'm going to pull a vacuum. We're going to vacuum impregnate it. And so he built a machine. I don't want to disclose how he did it because it's his IP and we may reproduce that later for other companies. But we did it. And we took polypropylene board short material. We vacuum impregnated it and we sent it to Oakley to be tested. And not only did it pass, they never were able to wet it out. All it had was water when they submerged it. All it had when they shook it out was bound water on it. And there was no reason to dry it out because it was already dry. They couldn't wet it out.
That's amazing.
So they were impressed and they said, wow, we've been working on this problem for 2 years. Who knows how much money we've spent on it. And you guys solved this problem in about 60 days. I think it took us 30 days to build Jim's machine, another 30 days to, test some fabric and
test it out, right?
So that's when I realized that his theory about small and mid-sized companies doing the innovation and then companies like Oakley, licensing it, that this was a powerful thing. We've done a lot of projects for a lot of people, but I want to shift gears real quick and talk about our new scientists. So
yeah,
I was a presenter at a textile event called Textile, and they do one in Europe and they do one in North America. So it's called the TTNA, but it's Textile North America. And I was very lucky to get invited to go speak about our research and projects that we had done. And I was leaving the stage and there was a young guy coming up and we kind of like shook hands and his name is Rocky Chandran. And at the time he was working for Triad Polymers as an extrusion chemist. And Rocky gave me his card and he called me and he said, I'm very interested in what you're doing and I want to work with you. And I want to talk to you about it. And I said, okay. And Rocky called me up and he came here and we got to talking and he said, I'd like you to give me a job. And at the time, Jim was still working for us and a company of our size doesn't need 2 PhD scientists. And I said, sorry, Rocky, we're covered up. We really don't need you. And he took a tour. He looked at all of our equipment and he said, I really want to work with you, Matt. And I said, I don't have any job openings for you. Well, Jim retired and I was on a project where we were applying medicine to yarn and we were doing it for another company. And my customer was a knitter and their customer was a very famous bicycle brand. And they wanted CBD oil on yarn for pain relief. Now, this was 2019, and this was right when the Olympic Committee endorsed CBD oil for pain relief. So this mountain bike brand went to their knitter and said, get us yarn with CBD oil on it for pain relief. And they came to me and said, can you do it? And I BS'd them a little bit and said I could do it, even though I didn't know I could do it. Because I had learned from Jim that if you say no, you don't get the work. And sometimes you fake it till you make it. But I called Rocky up and I said, hey, Rocky, can you show me how to put CBD oil on yarn for pain relief? And he said, yeah, I did that when I was at Harvard. He said, didn't you read my white paper? And he had like 7 white papers that he sent over to me. And I read 5 of them. And I guess it was in the white paper I didn't read. And he was a little offended. He said, I sent you that white paper. I know how to do that. And I said, hey, don't kill me. Just teach me how to do it. And he started his spiel and he said, well, Matt, he said, to get a good coverage, we're going to need a master batch extrusion. And I cut him off right there. And I said, wait up. I'm not an extruder, and I sure don't want to go somewhere and do master batch extrusion, because I know from people in the industry that when you do that, you've got to clean out that machine after you run anything through that machine. Even if it's something black or something purple or something blue, they run about 1,000 pounds of material through there just to clear out the remnants of the run. And I said, Rocky, you've got to do it at our location on our equipment. And I said, I'll tell you what, if you can teach me how to do that, I'll give you a job. And he said, okay. And he's very, he's a brilliant guy. I mean, he went to Harvard. He's got a degree in nanoscience from UNC Greensboro. Very soft-spoken, very intellectual, super guy. He said, let me think about that. 5 days later, he called me and he said, check your inbox. And I checked my inbox, and he had written me a white paper on how to apply CBD oil to yarn in our factory with our equipment and make it wash durable. And he said, and if you want, I'll come in, I'll show you how to do it. And the learning curve was pretty steep, I will say. So we bought CBD oil and we heated it up with a hot plate and a scientific mixer. And we got it to the correct temperature where it could be applied to yarn. And then we used a proprietary machine that Jim built us, which is a bonding range. And we bonded the oil to the yarn. And the oil heated up. It smelled like people were smoking marijuana. People came into the lab area and they said, hey, do you guys need a pizza or some chips or something? And the viscosity changed, and then the machine spit the oil out everywhere, all over the machine, all over the wall, all over us. We were cleaning for about 3 weeks after that mess up, and then we figured out a better way to do it. But I hired Rocky. And so here's the beautiful part of my journey, how I got here. Rocky was such a great guy. This was 2019. He said, Matt, do you want to learn about yarns that heal your body? And I said, no, my business is cut resistant safety clothing, and my business is Conductive Textiles. We were on an Air Force heated glove project at that time with outdoor research and ADS, who's a huge military defense contractor in Virginia Beach. And we had bigger fish to fry. I said, no, I really, I'm not interested. And I think he was sitting at the seat I'm sitting in now in our conference room, and I was sitting to his right. 3 months later, we were in full-blown pandemic, and our revenue dropped by about 50%. And we went from 2 shifts down to like skeleton crew, 1 shift. And we really didn't have a whole lot to do. We were selling 95 masks and isolation gowns and nitrile gloves like everybody else in the textile industry. We made the pivot. We were like, all right, our regular business is kind of out the window. What can we do to keep rolling? And like everybody else, we scrambled and hustled to keep the doors open and the lights on. And
really smart move. Yeah.
And so at that point, I said to Rocky, okay, teach me about yarns that heal your body. And he said, I'd rather you read a paper, a peer-reviewed medical journal article from the Harvard School of Dermatology that was published with me and my mentor, Dr. Hamblin. And I said, okay. And so I read the paper. And when I read the paper, it read like science fiction. It talked about regrowing Achilles heel in mice using nanoparticles and fabric. It talked about using light to heal your body. It talked about all these things that I had never heard of. And I basically wasn't even sure I believed it. And I went back to him and I said, hey, if all of this is true, like this is fantastic. This is way bigger than anything
right?
that I've ever thought of. And he said, look at the name on the paper. He said, Google Dr. Michael Hamblin. He's now retired from Harvard, but he said Hamblin was an expert in 2 things. He was an expert in PDT, or photodynamic therapy, and LLLT, low laser light therapy. But Hamblin took these techniques and he applied them to textiles. So that's pretty unusual. So
really unusual.
Yeah, Rocky said, if you're interested, if you're really interested, you want to learn how to do this, I will teach it to you. And so I said, okay. So we started working with these yarns, and we worked with all different versions of the yarns, but one involved nanoparticles. And Rocky searched for 10 months to find the correct nanoparticles. And he's a very hardworking guy. And being his employer, I had my foot on his rear end. And after about 3 months, I was a little upset. And I said, hey.
Yeah, you're probably losing hope that it's possible, right?
Google it. Where are the nanoparticles? And he's like, Matt. So what he was explaining to me was that different shapes lend themselves to different applications with your body. So nanoparticles can be spherical, they can be pyramid shape. you can influence them to be different shapes, and different shapes influence your body in different ways. And him having a degree in this, he knew exactly what he wanted, but he couldn't find it. So he eventually found it, and we got it shipped to us. It's got to be shipped with dry ice. It's got to be kept extremely cold. And we applied the nanoparticles to the fabric. We did 3 different versions of the fabric, and we sent it to Texas A&M, and we did an animal study, which, at the time was a little controversial, probably still is. People don't like testing on animals, but we couldn't afford testing on human beings because testing on human beings costs hundreds of thousands of dollars. I mean, minimum $250,000.
Right.
So we got the Texas A&M test, and I paid the money to Texas A&M. And as a small business owner, I was apprehensive, is like an understatement. I was worried. This was, at the end of the day, more than $20,000, under $30,000, but it was a lot for us. And if it didn't turn out well, it was going to be a huge waste of money. And I went to Rocky and I said, Rocky, are we going to pass this test? Are we going to do well? And he said, Matt, I ran this experiment when I was at Massachusetts General Hospital. He said, I've seen this movie and I know how it ends. And he said, in a clinical setting, even a small increase in healing, like a 5% increase, is considered significant. And we will have more than a small increase in healing. He said, so don't worry. We've got this. And the results came back from Texas A&M, and it blew my mind. We just got them to sign off on the results. But the fabric that we did with nanoparticles reduced scar tissue, the width. I want to be very specific. They measure in micron meters the width of the scar. And the conclusion was not obvious. I got the conclusion, and it was written by a veterinarian. And it talked about necrosis of the tissue, and it talked about scar width, and it talked about healing. It said we had advanced, in all the fabric groups, we had advanced healing in 7 to 14 days. But the nanoparticle group showed a 48% reduction in scar width. And that blew my mind. So I just took those results of the study and I dropped it into Excel, as Jim taught me, and I plotted the rate of change. And my jaw dropped. I was like, wow, this really worked. I kind of, spoiler alert, I kind of got ahead of myself. When I went to Rocky and we were waiting for the testing to be done, Texas A&M invited us to go out there and watch it. And he said to me, they're going to shave the animals, they're going to make an incision, they're going to put in sutures, and then they're going to cover it with a pressure bandage. And then our fabric is going to go on top. And he said, as much as it would be fun to go to Texas, he said, I think we could see that on a Teams call or something. We don't need to be there in person to see that part.
Right.
And I said, okay, Rocky, but which group is going to do the best? And he said, nanoparticles. And we had tried dye with medical grade light. We used a bunch of Hamblin techniques to try to create the effect of healing your body. But Rocky said, nano is best. And I said, why is nano best? And he said, it's the size. He said, the size is so small. I mean, most people don't understand what nano means, right? A millionth of a meter, a millionth of a millimeter.
Right. It's so microscopic you can't even fathom that. Right.
Right. And we did some work with graphene too, which is a 2D material. And I struggled for like 2 weeks with this 2D material. Wait, it's got an x-axis and a y-axis, but there's no thickness. And Rocky said, no, it's one molecule thick and visible light passes through it. And when visible light passes through something, then it has no thickness. But he knew that nano would do the best, and nano did the best. So that was really mind-blowing. So now we're at the point where we're looking for FDA registration, and we're looking to get this into hospitals so that people that are injured can have this fabric and heal their body with it. So
that's amazing, Matt.
Yeah, it's been a fantastic journey. And then we've got another startup called Volt AI, because we've been working with sensors from NASA since 2018. So we make a yarn that's electrically conductive, and NASA created a technology called SONSI-C. And this was a brilliant scientist named Dr. Stanley Woodard. And Dr. Woodard printed electromagnetic copper on circuit board in the shape of a spiral. And then he introduced a radio frequency. And then he had a glass of water, and he put the sensor next to the water. And on the network analyzer, he could see if the glass was empty or full based on the signature that was on the network analyzer. And then when he poured the water out, he could see the rate of change on the network analyzer. So my POC at Langley is a guy named Ken Dudley. Ken told me that Stan, he was walking down the hallway in Langley, and Stan said, "Hey, Ken, come here, check this out. I created this sensor, and it works with the electromagnetic spectrum. And look, I can see the rate of change if I pour the water out of the glass." And Ken's job was to launch communication satellites into the Earth's orbit for communication with the International Space Station. And Ken said,
Right.
"Stan, that's cool, right? It's very interesting, but I'm on a deadline." Well, 2 years later, NASA went to Ken Dudley and said, "Embed yourself with Dr. Woodard, figure out everything you can about SANS-EC and how it works, and then let's use it throughout the agency." And they do today. They use it to tell how much fuel is in the gas tank of the space shuttle. They use it for detecting lightning strikes. They've used it for electrical anomalies, air pressure in tires. It lends itself to everything. So we've been working with SANS-EC, and we've had a lot of versions of electrically conductive yarn with our division Volt smart yarns. And when we made sensors out of it, the sensors were off the chart. The NASA sensors were resonating at maybe -8 to -15 decibels, which on the network analyzer is like an inverted peak. It's a sweep on the network analyzer. Our sensors that we made were resonating at -35 to -50 decibels, which for NASA was like 4 to 5x what they were seeing with their sensors. Go back to Jim Threlkeld. Jim said it's a no-brainer. But Jim was always very calm about everything. I said, "What do you mean it's a no-brainer?" He said, "Think about copper on a circuit board. The circuit board is stiff. The copper's stiff. It doesn't lend itself to resonating, vibrating like a tuning fork or a bell or a guitar string." But he said, "Think about the embroidery. We embroidered conductive yarn into a felt backing material." He said that felt backing material is flexible. It's a fabric. And the copper in the Volt yarn is 44 American gauge copper wire. It's about the diameter of human hair. He said, think about that copper wire in that felt. Of course, that's going to resonate and vibrate better than a circuit board with copper. So for Jim, it was fundamental, right? He's like, of course it's better. It's a better medium. So we've been working with these sensors now for a long time. And I feel like I missed a couple of points in there. And one of them was that we started working with the University of Texas with the sensors to detect infection. And University of Texas did a beautiful job. They took our sensors and they put it on people that had surgery, and they were able to characterize healthy tissue, inflamed tissue, and infected tissue. And then we developed AI and machine learning software to predict who would get an infection. So about this time, like all startups, right? Because Volt AI is a startup, we needed money. We needed money, to flesh out all these use cases and commercialize. So we went after this NSF grant during COVID. And the NSF grant, we made a proposal to put a little embroidered sensor in the collar of a polo shirt. And then we could introduce radio frequency during class. And we could measure children in schools to see if they were getting a spike in their body temperature that would indicate a wave of COVID infection. Well, NSF likes sexy research. NSF funds things that are a long shot, but if they come true, it goes big.
Right. Game changers, right? Yeah.
Yeah. We had 7 PhD scientists on that proposal, including Yulia Kostarova-Beller, who's on our board of advisors. She was also a former NASA scientist that worked on SANS-EC with Ken at the SANS-EC team at Langley. And they denied to fund us, but they invited us to resubmit. And what they told us was they didn't think we had a big enough organization. We were asking for $2.5 million and like a 24-month study. And they said, you need more PhD scientists. You need more industry partners. You need a bigger platform of people. They liked the proposal, but they didn't feel it was right to get funded. And what I learned from that is that there's a lot of cost that goes into proving new technology. And so we've refined our pitch and refined our pitch and refined our pitch. Well, one of the things that we learned at that time was that University of Texas was determining inflamed and infected tissue by change in temperature and change in pH. They had also submitted an NSF application at that time and told NSF that they were going to detect infection on people with our sensors using those metrics. And back at that time, change in temperature and change in pH was not accepted academically as an indication of infection. And that's exactly what the NSF said. So we didn't get funded and UT didn't get funded. And they told University of Texas, hey, that's not an established mechanism for detecting infection. But now it is. So now science has caught up And they are
And now you can
recognizing,
resubmit. Yeah.
yeah, a change in temperature with a change in pH to indicate infection. Sometimes we're ahead of the curve, sometimes we're behind the curve, but that got us to talk to military groups. And so when we were talking to military groups, we joined the North Carolina NBC, or the North Carolina Military Business Center, and they said, hey, we like what you're doing, and there's definite applications for warfighters. One of the things that they're looking for now, our government is looking for, is early detection of infection in the field. And so together with University of Texas and our sensor and our software, if you're injured and you've got a bandage, we can put a sensor on the outside of your bandage and we can detect if you've got an infection, and a layperson can do it. You don't need any medical training at all.
That's amazing.
Yep. And so we were at a North Carolina NBC meeting, and there's a guy named Bob Burton, and Bob Burton is the head of the NCNBC. And this was about a year ago. And he said to the whole room of people at the NBC, he said, how many people are using ChatGPT every day in your business? And there was maybe out of 30 people, like 4 or 5 hands went up.
Right.
And Bob Burton said, we're an interesting organization because we're a state organization, but we get funded by the federal government. We're paid by the federal government to line up small and mid-sized companies with military contracts. And he said, we were told by the federal government that we need to use ChatGPT every day. And he said, every hour you spend using ChatGPT is worth 100 man hours. So he said, if none of you have it, get it and start using it right away. So I got it and I started using it. And I started using it in ways that I never expected. Like, for example, we use it to create marketing material. We use it to create images that generate sales. We use it to create LinkedIn posts. But we also use it, and I got the pro account, right, because I don't want to share proprietary information with the world. And if you do have something proprietary and you don't use the pro account, it becomes public knowledge.
Right.
We've been using it to design products. And I'll give you an example of that. The software that we created for Volt AI, it uses machine learning and it uses AI, but it's not using ChatGPT. We started with NASA's program, which was Random Forest, but Random Forest is really outdated. I don't think people are using Random Forest anymore, or not. Now there's much better tools.
Right.
But recently I asked our software designer, what if instead of using our proprietary software, we use ChatGPT? And he said, you know what, I'll create a module and we'll try. And we got very good results. Forget the custom software that he designed. We got very good results just using ChatGPT to read the information from our sensors. But we had to create a workspace where we put in all the parameters of the sensors, how they work. And then once AI knew that, AI was able to interpret the data coming off the sensors perfectly. So I briefly, before we got on, we were talking about ChatGPT. And so I'm a big believer in it. I use it more than Google. Like, my kids will ask me a question and I say, well, let's see what ChatGPT says. And they're like, Daddy, why don't you Google it? And I said, yeah, but I like using ChatGPT.
Right. It's better. And you get the app on your phone, and next thing you know, that you use it for everything.
Yeah, I do. I use it for everything.
Yeah.
So just to kind of summarize, Supreme has been in business for 60 years, and I took over as the CEO in 2014, and I've been the sole owner since 2008. We're a high-tech yarn company. And I probably should have said this at the beginning, but we make body implant yarns for Boston Scientific. We do R&D for companies all around the world. Some will let us name them. Some, like the people with the swoosh, they don't want to be named. But we do work with everybody. And the reason that they like us is because we have machines that can create any combination of yarns. We do core and cover. So we can have multiple cores, 2, 3, 4, 5 cores. And then we can have covers in S and Z direction. We had done some work on an artificial heart valve that used yarn in it. And it was all continuous filament fiber, so there was nothing that could break off and get inside your body. But I asked the designer over there, how'd you find us? And he said, well, I knew about you guys from U.S. Army R&D at Natick, and they told me you guys had the best equipment and could create anything that I could imagine. Well, then he moved on to another company and he just kind of took us with him. So we're on projects now with everybody. And again, a lot of them have NDAs and a lot of them don't even want to be named. But I can tell you that we had yarn in the seats of the Tesla Semi that came out in 2019 for resistive heating. We did resistive heating gloves for the Air Force with outdoor research. We work with automobile manufacturers. We work with the people that are social media companies that have their own products electronic products. So we get to do a lot of cool, fun things, but a lot of it we're not allowed to talk about.
Yeah. But hey, listen, the fact that you kind of walk through the possibilities, like it's mind blowing what's possible and where you can see where things are at.
Right. So if I think about the future and the future of our company, I really see it being split into three companies. I mean, Volt AI is standalone, Heal is standalone, but Supreme makes yarn and Supreme makes safety clothing. And I think eventually safety clothing may become its own company. And the yarn may become its own company. And I've been lucky. I started out as a litigation attorney, and I ended up a yarn engineer. And then I remember in 2012 and 13, I was watching the wearable tech world, and it was very cool. Sensors on clothing. And I really had like wearable tech envy. And I felt like, wow, I'm wasting my time with these cut resistant fabrics, and people are doing sensors on clothing. And that seems really fun and interesting. And then, 10 years later, we're being named, one of the top 5 companies in the world for wearable technology. So it's my career has been a very interesting journey. And it's been a lot of fun. And Jim, one of the things Jim used to say to me, and I was asked to go speak at a church group for young adults who felt like they might want to own their own company.
Yep.
And they asked me to go and speak. And I gave them this quote that Jim gave to me. He said, the secret in life is to figure out what you like to do and then figure out how to get paid for it. And if you can do that, it's never work. If you do what you love, then it's passion, and you do it, you gladly wake up and do it every day. And I feel like that's where I am. I love what I do. I love creating things.
And what a blessing that is to be there.
Yeah. I love making things. And let me just say, I've had so many failures. I don't want anybody listening to this to think that it's been a golden journey and everything we touch turned to gold. I've made things that people didn't buy. I've developed technology that I thought was a good idea, that the price was too high and it commercially wouldn't work. Like I've probably made just about every mistake you can possibly make. But I think the beauty of that is that I've learned from my mistakes. I had a wrestling coach who said to me, sometimes when you win, you really lose because you get a pat on the back, but you don't learn anything. But when you lose, you take it to heart. You remember what went wrong and you work on it and you make sure it never happens again. And that's how I think of things. We've got to learn from our mistakes. And so I'm still making lots of mistakes, but I'm still learning from them.
No, Matt, thank you. Thank you for sharing all this. This has been really, really eye-opening, and I love the breakthroughs. And I can't wait to have you back and hear about Volt and how Supreme is. And who knows, it might be multiple companies by the time we talk again. But
hopefully. Well, Brent, it's an honor. I really appreciate it.
Yeah, I can't wait to get this thing up and live. But for anybody that wants to get in touch with you, we'll have all the links below, but tell them how to get in touch with you guys.
Oh, yeah, sure. You can go on our website, which is supremecorporation.com, or you can send an email to me. It's just my first initial and my last name, KOLMES@supremecorporation.com. And you can find me on LinkedIn. I'm easy to get in touch with.
Awesome. We're going to have all the links when this thing goes live. But Matt, thank you for spending this time with us. Thank you for sharing. And I know that anybody listening to this has learned a lot and gotten some really good ideas from you. So thank you.
Thank you. Thanks.
All right. That wraps up this episode of Future Proof Podcast, and we will see you on the next episode.
If you're ready to embrace change and lead with innovation, be sure to subscribe and never miss an episode. Thanks for tuning in to the Future Proof Podcast.